In this video, we're going to be solving some problems that involve using the scaling laws. So scaling laws are rules that objects and things in our world follow when their dimensions or measurements have basically been increased proportionally. And we can use what is known as a scale factor, as we talked about in our earlier proportional problems, to determine new sizes of objects. Now, scaling laws focus on sort of what happens to not only their dimensions, but also the area of the new shape as well as the volume of the new shape. So to start with this, we're going to actually go back to that Alice in Wonderland situation that we started this lesson with. So let's suppose Alice, after eating the cake, magically quadrupled in size. So quadrupled basically means that she grew 4 times larger. And when we say that 4 times larger, that 4 is actually our scale factor. And this would be the scale factor that would mean all of her dimensions, or her height, the length of her legs, the length of her arms, all of those things are lengths, those measurements are now 4 times bigger. So if we're asked what factor did her height increase by, height is just a dimension. It's how tall Alice is. So her height would have increased by a factor of 4. So her new height is 4 times bigger than her original height, which means if her original height was 5 feet, then her new height would have been 5 times 4, or 20 feet, which is huge. All right, the next question, we're asked about the amount of material required for her clothes. Now, if you think carefully about this, material used to make an outfit would actually be an area. And if we're increasing the dimensions by 4, I like to actually think about this in terms of a square. So if in an original square, I don't know, let's say it was 3 by 3, this would have had an area of 9. But in a square that's now been blown up to 4 times the size, my new side lengths would be 12 by 12, and its new area would be 144. Notice the area hasn't been multiplied by a factor of 4. What we actually find out is that area has actually been multiplied by a factor of 4 squared. Since each of these dimensions, if you think about it, we had 3 times 4 and 3 times 4, so that new sort of piece to the area was the 4 times 4. And so here, what factor would that amount of material, that area of clothing, be needed? That would actually be 4 squared, or 16. So the new sort of the amount of material is 16 times more than what she originally needed. All right, the final one we're going to look at in sort of our sort of scaling laws deals with volume. So we're talking about a weight here, and weight, yes, is technically a volume measure. So volume now adds a third dimension. If you think about it, if we're looking at cubes, we have a length times width times height. And just like the area was that original scale factor squared, with volume, it's going to be that original scale factor cubed. And so in this case, that weight would increase by a factor of 4 cubed, which would be 64. So her weight is actually 64 times more now than it originally was. And just like with the area, that should make sense, thinking back to that cube. If we add a third dimension and when we blow it up even bigger, each of those new dimensions would be 3 times 4, 3 times 4, 3 times 4, 4, 4, 4. So 4 cubed is that new scale factor. So that's sort of the general idea of how scaling laws work. Now let's sort of use them within a context. that involves a little bit of percents. So we have Aaron here. He's 71 inches tall. So, here's Aaron. Ooh. Aaron. He is 71 inches. Tony is 13% taller than Aaron, but proportioned exactly the same way. I don't know, maybe they're brothers. So we have Tony here. Tony is taller than Aaron by about 13%, which means he's going to have the same height as Aaron with 13% added on. So what I like to think about with Tony's height is if I'm comparing it to Aaron, I have 100% of Aaron's height plus the extra 13%. That's the extra height of Tony. And so Tony's height is 113% compared to Aaron's height, which 113% isn't a scale factor, but we can turn that into a scale factor by turning our percent into a decimal. Well, all percents are out of 100, so if I want to figure out the decimal for 113%, it's out of 100, which would be 1.13. And that 1.13 is our sort of scale factor. So I could think of it as Tony's height is 1.13 times, larger than Aaron's height. And that idea actually helps us then solve this problem, because Tony's height, so that, the height we're looking for is 1.13 times whatever Aaron's height was, and his height was 71 inches. So that expression is going to find me the answer I'm looking for, which is Tony's height. And so in this case, 1.13 times 71 would actually be 80.23 inches. And so here was a way we took that scale factor. Now, if we were looking for the amount of material or the amount of material, like extra that Tony needed for his clothes, then we would take that scale factor and square it. If we were comparing their weights, just like in the Alice problem, again, I'd take that scale factor and I would cube it, because we're looking at 3 dimensions instead of just 1. Hopefully this sort of gives you a brief introduction to how scaling laws can help us sort of quickly figure out dimensions and sort of sizes of proportional objects.